What about mixtures? So mixtures then are going to be when we take these components or these elements and we start putting them together. We have three main types of mixtures. We have solutions, we have colloids, and we have suspensions. And we talked about matter. Everything is matter, right? And most of our matter exists as a mixture. So it's when we get two or more components mixed in together, they can be separated physically by straining or filtering. So let me walk you through the three types. We have the solution here on the left. The particle size is very small, and you can also see it here in the left, all right? And so this is when you take, an example would be taking table salt and dissolving it in water to form saline or salt water, okay? And so it's a solution, and it's a true solution because the water will actually break the bonds between the sodium chloride, and you get a truly dissolved solution. Next, we have a colloid. And a colloid example would be, so colloid is here in the middle in this image, a little bit bigger size, and it's on the right here in this picture. But a colloid, an example of that would be milk. And so milk is an emulsified colloid of liquid butterfat globules. So you've got these butterfat globules that are dispersed within a water type liquid. And so in suspension, you've got these molecules, or in the colloid, you've got these molecules that are hanging out in the liquid. And so that makes it cloudy. Then you have a suspension. The suspension is going to be with a little bit larger molecule sizes. An example here is flour and water. And it looks to be a little light blue, not so much in this picture, but if you did it at home, put some flour and water, it would be because the blue light is scattered from the flour particles to more to an extent than red light is. But anyway, the flour is going to be bigger particles, and they will literally just sit in the water. So going through these solutions again, if you have so let's look at each type specifically. So looking at a solution, you have solutions that are homogeneous mixtures, meaning it's all of one solute in a solvent. And this can be usually transparent, so atmospheric air or seawater. You can have diluted, as we have down here, all the way to concentrated. And a solution is going to be the solute particles are so small that they don't settle out, and they basically can be absorbed by the water or the solvent that they're in. So solvent is going to be what you put the solute in. It's going to be the thing that's in the greatest amount, usually a liquid. So if you think of the water in sodium chloride or in salt water, that would be your solvent. The solute is present in smaller amounts. So in this case, for our salt water example, it would be the sodium chloride in salt water. Okay, so the solute is the smaller amount of particle. The solvent is present in larger amounts. There's another example. So if you were to pour table salt into the water, or sugar even, you've got your solute you're pouring into your solvent. Colloid, like the milk fat globule particles that were in a water type liquid, are known as heterogeneous, meaning they've got different things in them, and they're translucent. They're not transparent. The cytosol or cytoplasm is an example of that. So these large solutes are not going to settle out of the solvent. Remember, our solute is the smaller amount, and they're in the solvent, but they're not going to settle out. So an example of this is gelatin. If you just think of Jello, it's a colloid. Suspensions are last type of mixture is going to be also a heterogeneous mixture. So it's different molecules all combined together. And these large solutes that are usually visible tend to settle out. So a good example here is blood. If you spin a sample of blood down in a centrifuge, then the heavier particles are going to fall to the bottom. The lighter particles will be separated to the top. And so again, it's a heterogeneous mixture, lots of different solutes, and they will settle out in a suspension.